So in this uh, lecture, we will discuss the regarding the different regions belongs to the optical fiber. So this is the diagram of optical fiber. Here the yellow portion is represent the core, and this between the black and yellow portion, this is the central region. We'll call it cladding, and this black portion we'll call it the jacket. So they mainly we have three regions, and in this optical fiber, the signal is propagating through only through the core region. This is central region. If any signal which enter into the cladding region, that will not uh, re-enter in the core region, or we can say that the signal will be lost. So this is the parts of the fiber, and here more thing we take into the consideration, that the refractive index of the core region is N1, and the cladding we have of material which has slightly different refractive index. So now, for example, when we fabricate the optical fiber, we will make use of glass or plastic, and here we will consider that the material, the core material must be transparent to the optical frequencies. So for example, in the case of the plastic fiber, we will make the use of polystyrene, polymethyl methacrylate, PMMA, that can be used as the core, and we use the cladding material is silicon or Teflon in case of the plastic optical fiber. Here, as in case of the if we want to make the fiber using uh, glass, in that case we will take the mixture of the metal oxide and silica. For example, germanium oxide plus silica oxide or silica, and that mixture will use for making the core, and the cladding for that purpose we will make the use of the silica. Uh, so this is the material which we use for making the uh, one of the materials for making the core and cladding. If we use the plastic and plastic optical fiber, and for the uh, glass optical fiber, and the material must be transparent at the optical frequencies. This must be the condition for making the for using in the optical fiber, you can say. So another is that we can discuss the classification of the optical fiber, and here we make the classification of optical fiber on the basis of how many modes, propagating modes, what is their number. On that basis we can classify. So here one we have the single mode optical fiber, and another classification is multi-mode optical fibers. So in case of the single mode fiber, here this diagram, here we have the diameter is very small, 8 to 10 micrometer in case of single mode, and here this red line is arrow is representing, this is representing the, there is a only this signal is propagating through this arrow. So there is only one signal is propagating in the optical fiber, and here this is the multi-mode optical fiber, and here this core diameter is large, and here we can say that here we have more number of signals, they can propagate it through the fiber. Here I am showing here three, but large number of the signals can be propagated through the fiber. So this is regarding the multi-mode fiber. And another is the classification which we can make on the basis of the index profile, or you can say on the basis of how the refractive index vary within the core region. So here this is classification is further we classify in two categories on the basis of index profile. One is step index optical fiber, and another is graded index optical fiber. So here this is the yellow portion is representing the core region, And I have drawn here, this is the graph. Here along the y-axis I have taken the radial distance, and this belongs to maybe the center of the core region. And along the x-axis, negative x-axis, but here we are considering only magnitude, we are taking the refractive index along the length of the fiber, you can say. And here the value of, I have denoted dotted line which is touching this x-axis, which is n2, and at n1 here the solid line is touching the x-axis, which is n1, and here we can say that n1 is greater than n2 here. So now what is its significance, what is it is representing here? So this is representing here that if we notice here, if I extrapolate this line, so this is representing the only core region, and in during core region, if I move from, this is represent central portion, I will go move from the center of the core to core cladding region, or at the interface, if I move from here to core cladding interface, it is found that the value of the refractive index is constant, is n1, whether I will go upward or in downward direction. So this is what, as we reach the core cladding interface, there is sudden change in the refractive index, or refractive index changes from n1 to n2 at this interface region. So in this type of fiber where refractive index is constant throughout the core region, and there is a sudden change in the refractive index at the core cladding region, if we have fiber of this type, we will call it step index optical fiber. So this is one category, and another category is the graded index optical fiber. So in graded index fiber, again here we have drawn the index profile along, this is y-axis, and taking radial distance or diameter along this. Along here we are representing here refractive index along the x-axis. And here difference is that if you see that the at interface refractive index is n2. What if we move, for example, from center of core to core cladding interface, we found that this refractive index is not constant here, but it changes gradually within the core region. So here refractive index, we can say the function of r, or radial distance, and it is maximum at the center of core and changes gradually as we move toward the core cladding region. So if we have this type of fiber, so in that case we call this type of fiber is graded index optical fiber. And here another characteristic is that if we trace the path of the signal here, so it is sinusoidal type, whereas in case of step index fiber, it is zigzag path. Okay. And another difference is in case of step index fiber, low bandwidth, distortion is high in multimode type fiber, whereas graded index, we have high bandwidth for sending the signal, and distortion is low in the case of this graded index optical fiber. And another classification is based on the refractive index and number of propagating modes. We are mixing now earlier both parameters, number of propagating modes and refractive index. If we on that basis, we further classify into the three categories: step index single mode optical fiber, step index multi-mode optical fiber, graded index multi-mode optical fiber. So this is the diagram I'm showing, representing the step index single mode optical fiber, and here the diameter is 8 to 10 micrometer of the core, and here numerical aperture is small. In this case, dispersion is also negligible and high bandwidth. And this type of fiber is very costly, and it is used for installation under the sea or and you can say for the long distance communication. And for this type of fiber, we require for sending the signal, we require the monochromatic source like laser light source. And this is one of the fiber that we call it a step index single mode optical fiber. Single word means only one mode is exist within the fiber. Only one path and the signal they are tracing the or propagating through that uh, uh, path. Okay, so this is regarding the index. And another is the step index multimode optical fiber. So here this is step index and here is also refractive index is constant. Whereas in earlier case in the step index single mode optical fiber, here is also refractive index is constant throughout the optical fiber. Only it varies, it changes suddenly near the port cladding phase. Similarly, in the step index multimode fiber, the refractive index is constant within the core region, but it is changing near the core cladding interfacing. And here the diameter is more, and it may be the order of 16 micrometer or more. And here the large number of signals can be transmitted. Here I have shown one, two, three, four signals. They are transmitting simultaneously throughout the fiber, through this fiber, and more can propagate through this fiber. And the this fiber has cheaper in term of uh, money, whereas this has low bandwidth, high attenuation, suffer from intermodal dispersion losses because there is dispersion due to the intermodal dispersion within this fiber. So this is the another category of optical fiber, and another is graded index multimode optical fiber. So here again we have refractive index is not constant within the core region. It is changes as we go from center of core to cladding. The refractive index changes gradually. It is not the same, and the path is light follow the sinusoidal path within the core region. And this type of fiber is has the characteristics between the single mode fiber, single mode step index single mode optical fiber, and step index multimode optical fiber. That you can say that it has intermediate bandwidth, low signal attenuation, intermodal dispersion losses are reduced significantly in this case. And this type of fiber we use uh, uh, for installation fiber network in the intercity trunk. Okay, so this is regarding the classification. So, how